now I have this little remark about the domain of a differential equation. So basically, imagine that, say, we want to model the Singapore population, and we want to use the logistic equation in order to do that. Then the domain of the differential equation is the following. So the population has to be non-negative, of course, and if the initial point is 1965, because before that there was no Singapore, right, it means that the domain of this differential equation is this area in the plane TP. Or here is an alternative way to model the same scenario. You can try to think about why this is also a valid model. So here the 7 is the carrying capacity, so which we are trying to work with the scenario when the Singapore population approaches 7 million as times goes to infinity. But of course, since we have the logarithm here, now p cannot be, we have the division and the logarithm, so now p cannot be negative, but p cannot be 0 either, because we have 7 over p. But still, the initial point is 1965. In the next lecture, we are going to talk more about the domain, but my main message now is that it is convenient to assume that the domain of a differential equation is an open set in the plane Ty. And then a solution of a differential equation is always going to be a differentiable function that is defined on an open interval. That is also important. So which means that in the previous example, it is more convenient to assume that the interval for t where the solutions live is not the closed interval from 1965 to infinity, but rather an open interval from 1965 to infinity. But of course, since we want to include the point 1965 into the domain, that's why we put minus epsilon here. So it is kind of just more convenient to work with open intervals.